Hi, Bhuvandiputi. Good evening to all of you.
I'm going to sir.
Okay, last week we just started the lesson electrolysis and electrolysis of acidulated water. Acidulated water means acidified water. You know that water is H2O. It consists of H plus ions and hydroxyl ions. H plus ions and hydroxyl ions. By the term electrolysis, lysis means separation, electro means the electric current. The separation of the components of a compound by using an electric current. Electric current පාවිච්චි කරලා අපේ compound එක components වෙන් කරන ක්‍රියාවලියක්. Right? So we use a setup that contains 2 electrodes. Here we use carbon electrodes. We use electrodes. You can use whatever the type of electrode, but main requirement is not to react with the electrolyte. So these are the electrodes. Actually, we use carbon. Carbon means graphite. Graphite. Do you know graphite? Is carbon. 1 allotrope of carbon, graphite electrodes. Graphite electrodes are used. Commonly, we name them as electrodes. And we have to supply an electric current by using an external electric circuit. Solution consists of acidulated water. Actually, you acidulate this by using dilute sulfuric acid. Right. Here you have to know several terms. Yeah, this acidulated water is the electrolyte. So you know, you learn that electrolyte and non-electrolytes. That's the electrolyte we use here. Anyone remember the definition for electrolyte? මොකක්ද electrolyte එකක් කියන්නේ? Yes, electrolyte is
It
yes,
is a solution which conduct electricity.
yes, fused compound or aqueous solution of a compound. So that's fused or aqueous solution of a compound. Fused or aqueous solution. Fused state means රත් කරලා උණු කරලා ගන්නවා. water නම් එහෙම කරන්න අවශ්‍ය නැහැ. So that's already a liquid. But if you use sodium chloride, ලුණු වගේ එකක් ගන්න ඕන. If you use that sodium chloride like solid substance before the electrolysis process, you have to liquefy that. In that case, you have to heat it up to the melting point. එයාගේ melting point එකට රත් කරන්න වෙනවා. So when you heat that up to the melting point, we call that fused state of that compound. ඒ කියන්නේ ලුණු උණු කරපු අවස්ථාවක්. So if you get that fused compound, that means you have heated it up to its melting point, right? Okay, so next thing, aqueous solution, so that a compound has been dissolved in water, like here. So what is already water, that's covalent compound. Therefore, we have to use this dilute sulfuric acid to ionize that into H plus and hydroxide. Next, we have to supply an electric current for the separation. Right. Here, the positive terminal of the cell is connected to the positive electrode, and negative terminal of the cell is connected to the negative electrode. So this positive electrode is known as the oxidation reaction happens here. So we call it the anode. And the negative electrode, we call it cathode, because reduction reaction takes place. When you do this experiment, you can see the evolving of air bubbles from both electrodes, right? So you can observe the amount of air evolved from anode is 2 times lesser than the amount of air evolved in the negative terminal or the cathode. The reason behind that is the positive terminal attract the negatively charged ions OH minus, and negative cathode that attracts positively charged ion H plus. Is that only types of ions in this solution? No. The sulfate ions also exist, but finally it exists in the solution, it remains in the solution, then it actually does not participate to this electrolysis process. It's just like a promoter, right? SO4 minus is negatively charged. Therefore, it's also attract here, but it's not subject to that process of oxidation. ඉතින් මට කියන්න පුතේ මෙතනින් හැදෙන gas එක කවුද? What's the gas produced here? So here it consists oxygen and this just H plus ions. H plus ions take electrons from here. So what is the gas evolving from this cathode? What's the gas evolving from the cathode?
Hydrogen.
Yes, that's hydrogen gas. Hydrogen gas. So what's the gas evolves in the anode?
Oxygen.
Oxygen. So you can see oxygen and hydrogen are the component elements contributed to make this compound water. Water කියන compound එක හදන්න contribute කරපු දායක වෙච්ච elements දෙක තමයි hydrogen oxygen. Now you can see these components are separating. So that separation is because of what? That separation is because of the electricity. Separation is called the lysis, and that lysis is due to this electric current. Therefore, we call that electrolysis, right? So I think now you can understand what happens here. Okay, so we have already taken this down. මේක ලියාගෙන අවසන් මේ වෙද්දි නේද? Right? හරි. මේක මේ විදිහට උගන්වන්න කියලා නෑ ඊළඟ කොටස. But okay, it's electrolysis of copper sulfate. Then we can understand how that electroplating of that. Before that, let's do this practically how to collect these gases that are evolving, right? Okay. Take down the topic. If you could not take down this note, you can watch the previous video. Then it will be okay, right? Collecting gases. Collecting gases that evolves in the process collecting gases that evolves in the process of electrolysis. Electrolysis of acidulated water. Here we use a special setup. Now we are going to draw that. Right. So this is the special setup we use. You can use yogurt cups when you do that in your school laboratory. So you have to seal it nice. So you have to use 2 yogurt cups. Here you use carbon electrodes. And you have to use test tubes. So here, water is filled acidulated water. And you have to use test tubes. And electricity has to be supplied from here. So this is also completely filled with water. And this is positive electrode. This is negative electrode. So why do you use these 2 yogurt cups? So you can make that steadily. So you can apply some wax over here. Then nicely you can seal it. Wax or silicone can be used. Okay, now tell me, you can see evolving of air bubbles from here. And when it goes up, it collects over here. So this is positive, and you can see the collection of some amount of air here. And the rate of the emission of air bubbles in this negative electrode, that means cathode, is very high. You can see 2 times air is collected here. 2 times the air as collected in the anode, right? This anode, and this is the cathode. So what is gas? Hydrogen, because this is negatively charged. H plus ions are attracted to here. Hydroxyl ions are attracted to here. That reaction you have to learn in grade 11, but I taught you last week. So this is oxygen. Oxygen gas. So this setup is used to collect the produce gases. Okay, draw this setup and send me okay when you have completed this. So the ratio between oxygen to hydrogen, you can see that's 1 to 2. The volume ratio also equals that 1 to 2. Yes, only one has completed this. Right. So next also a kind of electrolysis, but we use that for plating a metal on another metal on unmetal surface, but it must be a conductor. Plastic එක උනත් plate කරගන්න පුළුවන්, right? But it must be a conductor. So plating a metal on another surface, right? Before you learn that, you have to know the electrolysis of iron or whatever the metal containing solution. Metal එකක් දිය වෙලා තියෙන solution එකක් අපි සලකලා බලන්න ඕනේ. Right? Yes, who send it by using WhatsApp? Udari. Right, that's good. Nicely drawn. Okay, next take down electrolysis of a copper sulfate solution. මේක ඔයාලගේ පොතේ electrolysis කියලා හම්බ වෙන්නේ නේ, right? So, but that understanding is essential to study that electroplating. Copper sulfate. Here we use a solution of copper sulfate as the electrolyte. The same setup is used. Same setup is used. Carbon electrodes. Actually, that's carbon means graphites, right? The solution, a copper sulfate solution. So this is the electrolyte, but it has been dissolved in water. What's the color of this? Color is blue. Copper sulfates, you know, that's when water is available, its color is blue. When you heat that, it creates anhydrous copper sulfate, then that becomes white, but that in solid form. මේකේ වතුර තෙතමනේ පොඩ්ඩක් හරි තිබ්බොත් නිල් පාටයි. Solution is compulsorily blue color, right? And it has been dissolved in water. Therefore, in this solution, you can see ions from water. Water වලින් ලැබෙනවා මොනවද ලැබෙන ions? Solution එකේ තියෙනවා H plus ions, hydroxyl ions. You know that. කලින් දන්නවා. වතුර තිබ්බොත් H plus and hydroxyl ion exist. In copper sulfate, වතුරදී මේ දෙන්න වෙන් වෙනවා Cu2 plus and SO4 2 minus. U විතරයි simple, අනිත් ඔක්කොම capital, right? Copper, that's cupric ion Cu2 plus, sulfate SO4 2 minus. So these are the ions in the solution. So what happens when you do that? So let's learn that next. So could you please take this down? Right. So these are the ions from these compounds, right? From water, these H plus and hydroxyl ions are created in the solution, right? From copper sulfate, Cu2 plus and SO4 2 minus ions are created. So this is a positive terminal and this is a negative terminal. Or you can tell it positive electrode and negative electrode. So as oxidation reaction happens here, last week I explained that as oxidation reactions happens, so this electrode is said to be the anode, while the other electrode is known as the cathode. Okay, as this is positively charged electrode, negative ions, hydroxyl and sulfate SO4 2 minus. So they are attracted here. Hydroxyl ions, SO4 2 minus ions are attracted to this anode. And this negatively charged, this means in cathode. So what are the ions get attracted? H plus ions are attracted as well as Cu2 plus ions are attracted. But according to the reactivity, ප්‍රතික්‍රියාශීලීතාවය වැඩි හයිඩ්‍රජන්ගේ කොපර් එක ගත්තාම. So you can learn that in grade 10. Right? ඉතින් පුතා මේ මෙතනින් electrons ගන්නේ දැන් මේගොල්ලෝ පිට කරලානේ මේ positive charge වෙලා තියෙන්නේ. ගන්න පුළුවන් H+ ද Cu2+ ද මේ දෙන්නගෙන් කවුද electrons ගන්න? පිට කිරීමේ හැකියාව වැඩි නම් hydrogen. That's oxidation capability is with hydrogen. But reduction capability reducing වෙන්න පුළුවන් හැකියාව තියෙන කාට? That capability is with Cu2+ ions. Therefore, it takes electrons මෙතන මේ copper, you know that positive charge coming from positive to negative, right? Positive to negative. Positive. And electrons are flowing negative to positive. So electrons are coming through this. Electrons in one. Electrons come. And that electrons are accepted by Cu2+. මෙයා electron දෙකක් ගන්නවා. It takes, look at this, Cu2 plus 2 electrons. So what is formed? Copper paramanu, copper atoms හැදෙනවා. That's neutral in charge. මෙයා positive charge වෙලා තිබුණේ යාගේ electron පිට වෙලා නිසා. Now, in this process of electrolysis, it gets that electrons, a couple of electrons. ඉතින් මේ positive charge දෙක neutralize වෙනවා negative electron දෙකෙන්. So that produce copper atoms starts to deposit. මේ උඩ නෙමෙයි මේ වතුර තියෙන කොටසේ copper deposit වෙන්න පටන් ගන්නවා. It starts to deposit. This just like plate in this metal with copper. හරියට ලෝහ ගෑවා වගේ. ලෝහ ආලේප කළා වගේ. So we can see that plating of copper in this cathode. Right? So your observation, first one, you can see in this anode, here you can see hydroxyl ions. It consists oxygen, as in earlier cases, it starts to evolve a gas. Actually, that gas is nothing but oxygen, right? Evolving a gas near the anode. මේක හරියටම ඉගෙන ගන්න. So step by step, I am teaching you how that electroplating is continued. මේ anode දෙක වෙනුවට මේ carbon rod එක ගලවලා මෙතනට ලෝහයක් සම්බන්ධ කරනවා. ඇයි? What's the reason? Why do we connect a metal? The plating metal is connected here. ඇයි එහෙම කරන්න කියන එක කියලා දෙනවා. Right? So what happens to the solutions, color of the solution? Another thing you can see in the cathode. Copper starts to deposit. Copper starts to deposit over the cathode. Copper starts to deposit over the cathode. Cathode එක මත copper තැන්පත් වෙනවා. උඩ තැන්පත් වෙන්නේ පියාඹන්නේ ඒගොල්ලෝ, right? It starts to deposit. Another observation you can make. Now, what gets deposited? How the deposit වෙන්නේ? Copper. Copper deposit වෙන්නේ. So these copper ions is the reason for the blue color of the solution. Copper ions are the reason for the blue color of the solution. මේ ද්‍රාවණයේ නිල් පාටට හේතුව මේ copper Cu2 plus or cupric ions dissolved in solution. මේ solution එකේ තිබ්බ Cu2 plus ion තමයි නිල් පාටට හේතු වුනේ. But now what happens? දැන් මොකද වෙන්නේ? Copper starts to deposit on cathode. Solution එකෙන් අයින් වෙලා cathode එකේ deposit වෙන්න ගන්නවා. දැන් නිල් පාටට මොකද වෙන්නේ? blue color එක අඩු වෙනවා. Blue color of the solution decreases. කාටද කියන්න පුළුවන්ද? Can anyone suggest? කාටව යෝජනා කරන්න පුළුවන්ද සර්? ඔය blue color එක අඩු වුණොත් එහෙම copper ඉවර වෙනවනේ. එතකොට copper deposit වෙන්නේත් නැතු යයි ටික වෙලාවකින්. ඒ නිසා සර් අපි copper level එක අඩු වෙන්නේ නැති වෙන්න මෙන්න මේ දෙක කරමු කියලා. You have two options. Option දෙකක් තියෙනවා. One method is you can dissolve copper sulfate more and more. Right? Continuously you can dissolve copper sulfate, but that's not practical. Automatically මේ පැත්තෙන් copper atom දෙකක් deposit වුණොත් මේ පැත්තෙන් දෙකක් එන්න වගේ ක්‍රමයක්. Any volunteer? අනේ සර් මේ ඌව වැඩක් නෑ අපිට ඉන්නකො මේ ලියා ගන්න. සමහරු දැන් අපිට ඌව වැඩක් නෑ. අර මාධ්‍ය වාර්තාකරු වෙන්න දෙන්නේ අනාගතේ. නේද? එහෙමනම් ඒ ස්කිල්ස් දිනු කළාට කමක් නෑ. No idea. Right. ඒක තමයි මේක කියලා දුන්නේ. කෙලින්ම එකපාරට ඒක කියලා දෙන්නේ නැතුව. Right. Blue color of the solution decreases, but you can keep that blue color constant. ඒ කියන්නේ copper ප්‍රමාණය අඩු වෙන්නේ නැතුව solution එකේ තියාගන්න පුළුවන්. You can take a copper rod. මේ carbon anode එක වෙනුවට අපි copper anode එකක් හයි කරමු. Right? එතන තරු ලකුණක් දාලා ලියා ගන්න. Blue color is due to ඔයාලා මගෙන් ප්‍රශ්න අහන්නේ නැත්නම් තව හුඟක් ප්‍රශ්න අහන්න ඇයි සර් copper blue color වෙන්නේ? කවුරුත් ඇහුවේ නැහැ මගෙන් කියලා දෙන්නේ නැහැ. Right. කවුරුත් මගෙන් ඇහුවේ නැහැ ඇයි සර් copper blue color වෙන්නේ? ඇයි ඉතින් copper වලට මොකද තියෙන අමාරුව නිල් පාට වෙන්නේ? ඇයි කොළ පාට වෙන්න බැයිද? රතු වුණොත් හොඳ නැද්ද? ඒ වගේ වහන්න පුළුවන්. දැන් කියලා දෙන්නේ. හරි? මම බලන්න හිටියායි කියලා. ඒක කියලා දෙන්නේ grade 11 වලදී. Right? හිටියොත් කියලා දෙනවා. Blue color of the solution decreases. Blue color is due to මට අමතක වෙලා කියලා දෙයිද නැහැ. Cu2 plus ions. All right. How to make them constant? මම ඊට ටික එතනින් ලියන්න, right? Due to continuous deposition. Continuous deposition or removal from the solution. Continuous removal of Cu2 plus ions from solution. Blue color decreases. Blue color decreases. Okay. To keep the copper ions level or keep the blue color level constant, yes, carbon anode is replaced by a copper rod. Carbon anode can be replaced with carbon anode can be replaced with a copper rod to keep the Cu2 plus ion level or Cu2 plus ion level එක කියලා කියන්නේ නිල් පාට. Keep the Cu2 plus ion level constant in the solution. ඇයි ඉතින් එහෙම කරන්නේ අපිට නිකන් ඉන්න බැරුවටද එහෙම කරන්නේ? What's the reason to do so? What's the reason to do so? ඕ නැත්තම් කවුරු හරි කෙනෙක් තඹ පාට කරගන්න මෙතනින් මොකයි මුද්දක් හරි පෙන්ඩන්ට් එකක් හරි තඹ පාට කරගන්න. තඹ නෙමෙයි ඉතින් රත්තරන් පාට කරගන්න. හරි? මෙතන හයි කරලා බලන් ඉන්නවා. ටික වෙලාවකින් තඹ ඉවර වෙනවා සොලියුෂන් එකේ. දැන් කොච්චර බලන් හිටියත් තඹ පාට වෙයිද? After completely deposited copper and the solution becomes colorless. එතකොට solution එක නිල් පාට නැතුව ගිහිල්ලා අවරණ වෙනවා. ඒ කියන්නේ copper නෑ. දැන් කොච්චර ප්ලේට් කරන්න බලන් හිටියත් ප්ලේට් වෙනවද? No. That's why. That's why we have to supply that's depositing metal ions continuously to the solution by installing a metal rod with that metal type plating. Right. So these are the observations evolving a gas near the anode. So that's oxygen gas. Copper starts to deposit over the cathode. Blue color of the solution decreases. So we have written blue color is due to the Cu2 plus ions. Due to the continuous removal of Cu2 plus ions from the solution, that means due to deposition, blue color decreases. Carbon anode can be replaced with copper rods to keep the Cu2 plus ion level constant in the solution. Okay, when you have taken this down, send me a message. Yes. Just kill a message done make you right? Right. So next we have to write, so what are the advantages or what are the uses of this electrolysis? Take down subtopic, uses of the electrolysis. අතන බුදේ මේ electrolysis භාගයට කියලා දුන්නේ. හරිද? මේකේ තව තියෙනවා මේ මොනවද මෙතන වෙන්නේ? deposit වෙනවා කියලා මොකක්ද වෙන? So you have to write this half reaction. You have to write oxidation and reduction reactions. And you have to get that complete reaction by combining both oxidation and reduction. ඉතින් ඒවා ටික ඉස්සරහට කියලා දෙන්නම්. Right. Uses of electrolysis. Use Okay, uses of the electrolysis. First one, for the extraction of active metals, සක්‍රිය ලෝහ නිස්සාරණයට. Okay, so what does it mean by the extraction of active metals? Active metals like sodium, magnesium, potassium, aluminium. So this is moderately reactive. So it also um, extracted by the electrolysis. Example, sodium is extracted by the electrolysis of fused sodium chloride. Okay, take it down. By the extraction of fused sodium chloride. Right. Actually, this is done by by using sodium chloride fused with calcium chloride, and it happens in down shell. A down shell like ඇතුලේ තමයි මේක වෙන්නේ. Right. So next thing you learned aluminium extraction by the electrolysis of bauxite. Bauxite, so this means aluminium, alumina. So we do that in whole shell. Whole shell like ඇතුලේ තමයි මේක කරන්නේ. Right. I think you have taken this down. So next application is you saw that a metal deposits on the cathode. So that can be used for plating metals. So take down for electroplating. Second one, for electroplating. For electroplating. Right. Example, for plating copper on iron. For plating, have you ever seen plating nickel on iron? යකඩ මත නිකල් ආලේපක. Plating chrome and nickel on iron. ඇයි රත්තරම් පාට කරනවා නේද? For plating gold on metals. Right. Next one is for the industrial manufacturing of caustic soda. Actually, when that aqueous sodium chloride is used for that, if you use its fused sodium chloride, sodium is extracted. And when it happens with more very diluted sodium hydroxide, sodium chloride, sodium hydroxide is produced. For the production of sodium hydroxide. We call that caustic soda. right? Here, sodium chloride solution with water. Water means H plus and hydroxyl ions. Sodium plus chloride. So when this is electrolyzed, what happens? Here's the positive and here's a negative rod. Okay, this sodium is attracted to negative, but nothing happens because hydrogen takes a place, H plus, it starts to evolve from there. And this side, so more chlorine that happens in more than 80% concentrated sodium chloride. So chlorine starts to evolve from this anode. So chlorine starts to evolve from here. Now chlorine is not there and hydrogen is not existing. So what remains finally? NaOH. So this is a method of producing caustic soda, right? So then also we use that sodium chloride solution 80% concentrated, more than 80%. Concentration එක 180ට වැඩිය ලුණු තිබ්බොත් මේ වැඩේ you know. අඩුවෙන් තිබ්බොත් වතුර වැඩි වුණොත් එහෙම ඔක්සිජන් පිට වෙන්න පටන් ගන්නවා. That's the reason, right? Now we can learn this electroplating. එහෙනම් ඔන්න electrolysis වල එක භාවිතයක් electroplating අපි ඒක ඉගෙන ගන්න යනවා. Sodium extraction තියෙන්නේ grade 11 වල. ඉස්සර grade 10 then grade 11 වල. Electroplating. Right. You already know that. So plating metal have to be used as the anode. Now tell me, the objects to be plated පාට කරගන්න ඕන එක හයි කරන්නේ anode ද cathode. Imagine that's a iron ring යකඩ මුද්දක්. You have to plate that, right? You have to plate it copper. So you have to plate copper on this. So what must be the solution? Copper sulfate, CSO4 solution. Now you know copper starts to deposit over this ring. Cu2 plus ion starts to deposit over this. And now what happens to the copper ion level in the solution? It decreases. Therefore, we have to supply that copper to the solution. So this is a copper rod, copper anode. What happens when this happens? Cu2 plus ions are generated. Copper ගෙන් electron දෙකක් ගන්නවා ඒක මේ පැත්තට යනවා. So that's copper. Cu2 plus ions jump into the solution. Then you can see this copper rod is dissolving gradually and it deposits on the object to be plated. So this is the object to be plated. ආලෙප කරගන්න ඕන object එක. So we connect that as the cathode. So this is the plate in metal. We connect it as a rod or plate as the anode. Copper, right? Okay. Another thing in the solution. So this solution, electrolyte. Electrolyte must contain ions of the plating metal. Ions of the plating metal. ආලේපවන ලෝහය අයනයක් වශයෙන් solution, for instance here Cu2 plus ion. ආලේප වෙන කෙනා solution එකේ අයන් එකක් විදිහට තියෙන්න ඕන.
Can't hear, sir.
Sir, you are muted.
මම විහිළුවක් කළේ මේ ඔයාලා අවධානයෙන් ඉන්න බලන්න. right? හොඳයි නේ වුමනාවෙන් අහන් ඉන්න. right? Okay. So if you want to plate, so whatever the metal on an object. That object may be plastic or whatever the material. Plastic with ornament plate කරන්න පුළුවන්. Right? So you can plate that. But before that, you have to apply graphite layer, next a copper layer, then nickel layer, finally a chrome layer. එහෙම ප්ලේට් කරපු ප්ලාස්ටික් වීකල් වල එහෙම වාහන වල එහෙම තියෙනවා. තියෙනවද බලන්න ළඟ රත්තරන් පාට නැත්නම් රිදි ආලේප කරපු ප්ලාස්ටික් එකක්. Do you have? I think some pen clips you can see there, right? අදිසියකට එකක් හම්බ වෙන්නේ නැහැ. Right? There are lots of objects like that. Okay, so whatever it is. So it's object to be plated, that must be connected as what? Cathode, right?
Cathode.
And the metal on which the object, on which plating, right? The metal that plate on the object. So we have to connect as the anode. And in the solution, plating metal must be as the positive ion. That means cations. අපි උදාහරණයක් ගමු. You want to plate a gold, so this copper spoon, තඹ වලින් හදපු හැන්දක් උඩ ඔයාට gold means aurum au මතකනේ. You have to plate රත්තරන් පාට කරගන්න ඕන. So where to connect this spoon? Spoon එක අයි කරන්නේ කොහොමද? Anode or cathode?
Cathode.
That's cathode. That's cathode, right? Right. Next, what kind of solution you use? මොන වගේ solution එකක්ද පාවිච්චි කරන්නේ? ඒ solution එකේ gold ion තියෙන්න ඕනේ. Au+ තියෙන්න ඕනේ. රත්තරන් ion. So we can use that gold cyanide වගේ solution එකක් ගන්න පුළුවන්. Right? And to continuously provide gold, අඛණ්ඩව gold සැපයීම සඳහා මොකද පාවිච්චි කරන්නේ? You have to use a gold rod as the anode. So this is the concept of this electroplating. මේ තමයි electroplating වල සංකල්පය. Could you understand it? තේරුණාද?
Yes, sir.
Right. මේක තාම
Yes, sir.
මේක තාම උගන්වන්න පටන් අරගෙන නැහෙනේ. In some school it has been completed, but it yet to be started, right? Therefore, you have to study this clearly. Right, okay, let's stop here. So thank you so much for the participation. Have a nice night. God bless you.
Thank you. God bless you. Thank you, sir.